Good afternoon, physics students. Welcome to the third and final installation of our analysis of the pasta bridge experiment. So in our last lesson, we made a graph of our data where we plotted our points and drew our trend line. And we could use that trend line to help us make predictions about how different amounts of pasta that we didn't test, for example, maybe a bridge with 6 pieces of pasta instead of 5 or even 7, how those bridges might do in terms of holding cups of water. So this trend line helps us make a prediction about that. So this is a graphical way to make that estimation, but there's also an algebraic way. And the algebraic way is useful because sometimes we might want to make a prediction about something that's not even on the graph. Say we want to make a prediction about how 10 pieces of pasta or 20 pieces of pasta might do. So this graph, since we only made it this big, it's going to make it hard for us to make those predictions. But if we're able to find an algebraic way, we can predict almost any amount of pasta, how much water it could hold. So, algebra can be intimidating, but we're going to do it in a very simple, straightforward way. I'm going to show you every step, and you just need to follow along and write what I'm writing for your graph. Okay? So the equation that we're going to use, the algebraic equation that we're going to use, is of this form: y equals mx plus b. So this should look familiar to a lot of you who have taken an Algebra 1 or Algebra 2 class. And if it doesn't look familiar or you're a little fuzzy on it, no worries. I'm going to explain what it means for physics right now. So the y refers to the y-axis. So y means all the information on our y-axis going up and down. So for us in our experiment, y is the amount of water. So that is also our dependent variable. So y is our dependent variable. In this case, this was the amount of water. Okay? X, I'm going to write that here just so you remember. So this is our dependent variable. It's on the y-axis. In this case, that is amount of water. Our x-axis variable, or our x here, that stands for the x-axis variable, or our independent variable. Independent variable. Okay? This goes along the x-axis from left to right. X-axis, and then that tells us in this experiment that's the number of pieces of pasta. That's what we were changing up. So number pieces of pasta. Okay, and then there's two other parts of this equation, the m and the b. So the m, that tells us our slope. And what slope is equal to how steep our line is. All right? So slope is equal to how steep our line is. Just want to underline that or highlight that for us, because that's going to be a big part of our lesson today. All right, so slope tells us how steep our line is. The steeper the line, the greater value that m is going to be. So and for our experiment, that's going to tell us for every time we add one piece of pasta, how much more water does that one piece of pasta get us in terms of strength. Okay, so the stronger the bridge is, that means each piece of pasta allows you to hold more water. The line is going to get steeper. Okay? So the m tells us the slope. The b is the y y-intercept. Okay? That means if we draw the line all the way to the y-axis right here, where does the line start off at? Okay? So that starting point tells us where we need to begin to draw our line. So that value is going to be the y-intercept. Okay? So to figure out our equation, our y and x are going to stay as they are, but we need to figure out what our slope is and what our y-intercept is. Okay. So one thing you need to know about slope is that slope is equal to the rise over run. Okay? So what rise means is how much are you going up and down on the graph versus run, which is running across, or how much you go across. Okay? So a high slope means you're rising a lot while running not that much. Okay? And to find the slope, we'll need to first pick 2 points that are on the line. Okay, step 1, pick 2 points on the line. So on the line is very important here. We don't need to pick our data points that we plotted. We just need to pick any two points that are actually on the red line. And I usually like to pick 2 points that are not only on the red line, but are at a cross, because that's easy for me to figure out what the value of that point is. So I'm going to pick this one right here, because I see that it's right at that cross. And then I'm going to pick this one right here. So these 2 points are going to be the 2 points I'm going to use to find the slope. All right? So every point has an x part and a y part. Okay? So the x part comes from here. So the x part on this first point is 3.5 because it's in between 3 and 4. So first one is 3.5. The next part is the y part going up this way. So the y value on this point is, looks like 2.0. So 2.0. So this is point 1. So I'm going to label this x1 here, y1 there. And then we need one more point. I'm going to go to my second point here. The x value is 6.0. The y value, 3.5. 3.5. So that's x2, y2. All right. So now what we need to do is, I told you that slope is equal to rise over run. What slope is also, to find rise over run, we have to find the change in the rise. And remember, the rise is going along the y-axis, so we need to find how much did the line rise between y1 and y2. So we're going to subtract y2 minus y1 on the top. And along the bottom, we're going to find out how much did it run. So how much space is in between 6.0 and 3.5. So we got to do x2 minus x1. Okay? So if you have 2 points and you've labeled them like this, you can find the slope by plugging in your numbers for this. Okay? So that's what we're going to do now. Plug into slope formula. That's the slope formula right here. All right. So y2, 3.5 minus y1, 2.0. And that's over x2, 6.0 minus x1, 3.5. Okay, so first let's do the subtraction on the top and the bottom. 3.5 minus 2.0 is 1.5. 6.0 minus 3.5 is 2.5. And then the final step is going to be dividing those two values. So I'm going to use a separate calculator here. So we've got 1.5 divided by 2.5, getting us 0.6. 0.6. So this number has units. So the units are whatever the unit is for the y value, so 0.6 cups over the unit for the x value. So over 6 cups per pasta. And what this tells us is that for every piece of pasta that we add to our bridge, we're going to get another 0.6 cups of strength. So it'll be able to hold on to another 0.6 cups. Okay, great. So we've got our slope right here. So now we have our m. The next thing is we need our b. So I'm going to just write that right here. M is 0.6. Okay. So our b is, all we got to do is look at our line and we can see the starting point. So it's in between 0 and 0.5. So halfway between 0 and 0.5 is 0.25. Half of 0.5 is 0.25. Like half of 50 cents is a quarter, 25 cents. So that means our b is 0.25. Okay? So now, what does our equation look like? Well, like I said, we don't need to change the y and the x part. That's going to stay the same. So we've got y equals 0.6x plus 0.25. So now we have our algebraic equation. And making predictions with this is actually really easy. So we know x represents our x-axis, or number of pieces of pasta, and y represents the amount of water. So if we want to know how much water can be held by a certain amount of pasta, we just plug in that value for x and then solve, and we'll find out how much water it should be able to hold. So for example, if we put in 6 cups of water, so we did x equals 6, then what that looks like is we'll do y equals 0.6 times 6 plus 0.25. I'm going to figure out what that is now. So 0.6 times 6 is 3.6 plus 0.25 plus 0.25 equals 3.85. So that means 6 pieces of pasta should be able to hold 3.85 cups, or almost 4 cups of water. And if we look here, we're going to see that looks about right. It's holding, according to our graph, it's holding about 3.5 cups. So it's might not line up perfectly, but it's a approximation for this line, because there's going to be a little bit of human error when we're calculating it. That's okay. So now we can use this to predict other amounts. For example, like 10 cups of pasta, 10 pieces of pasta. So I'll try that right now. So let's say x equals 10. That means y equals 0.6 times 10 plus 0.25. So 0.6 times 10 is 6, plus 0.25 is 6.25. So we would expect, if we kept on going here, and we had a 10, that the line would be close to 6. All right. So what you need to do now is make your equation for your graph. How you set your graph up. You're going to find the slope, and then you're going to find the y-intercept. You're going to write out your equation, and you're going to test it for different amounts of pasta. So you're going to record your answers in the Google form, and you're going to take a photo of your slope calculations and upload that to the form. All right. Thank you.